Okay, this is 7.6 or 7.5, excuse me. This is solving special types of linear systems. And I know you've got these definition terms, inconsistent system and consistent dependent system. You do not need to know these names. I'm not going to ask you to recall these names. What I am asking you to know is that a linear system, equations, if you have no solution, there will be a time when you have no solution. And that's because you have parallel lines. Think about it. The solution to a system is where two lines intersect, right? It's the one point they have in common. If you have two parallel lines, they're never going to intersect. They're never going to have a solution that's common. So there is no ordered pair. There's no answer in the whole world that's going to make both of those equations work because they're never going to intersect. Now, kind of the opposite of that is a linear system with infinite solutions, and you can say infinitely many solutions or just infinite solutions. Infinite, not infinitely, infinite solutions. You can say infinite solutions if it's actually the exact same line. What's going to end up happening is you're going to have a line that you draw, and then somehow you're going to figure out that the other equation is actually the exact same line right on top of it. So your options are no solution for parallel lines, infinite number of solutions for lines that overlap, or it could be like other systems that just have one possible solution. Different methods to find whether or not this is a special type of a system. You can do this by graphing. So we can graph this system first, but to do that we have to get the y by itself. So 2x plus 1, and that means I start at 1 on the y-axis, up 2 and over 1. Down 2 and back 1, and there's my line. Now in the other equation, got to get y by itself to graph it. 2x minus 3. So start at negative 3 on the y-axis, up 2 and over 1. And if you look at these lines, and I kept going with my points and I drew this absolutely perfectly, these lines are never going to intersect. There is no solution to the system. No solution to the system because they are parallel lines. So it says no solution. Now, I actually could have told you that there was no solution right here. If two lines are parallel, they're parallel because they have the same slope. I knew they had the same slope in the equations because I got my equations into slope-intercept form, and then the slope of each of them was 2. So I knew right there that I had no solution because they had the exact same slope. So there's another option you can do. You can choose elimination. Any method to so let me show you how elimination would work. Well, coefficients, the exact my y's, I have y minus y. That actually disappears as has been eliminated, and I'm left with 4. Does 0 equal 4? No. And if it's not true, anytime we get a statement that's not true, that means no possible. If everything gets eliminated and you're left with a false does not equal 4, no. Can't. Your other special type of system is a linear system that has infinite number of solutions, and I'll show you what it looks like when you graph it. But remember, the whole thing is you've got to get y by itself equals negative x, minus 3. Remember, when we divide, you actually divide all of that, and since there's no number in front of this, this is actually negative 1/3 x minus 1. And so start at negative 1, and I'd go down 1 and over 3. And there is my line for that equation. The second equation of my system, again, I've got y by itself. This is 1 minus 1. And hey, they end up being the exact same line. If they end up being the exact same line, you can tell me that there are infinite solutions. We can't actually say all numbers because that's a real number and it's not a solution. It's all of the numbers that are on the line. So we just say that there's an infinite number of solutions. We can't list them all out. This is the substitution method. So this is going to show you what it's like when you get an infinite number of solutions using the substitution method. So for the substitution method, you've got two equations, x plus 3y equals negative 3, and 3x plus 9y equals negative 9. But to do substitution, you need to get one. Many of you forgot how to do that on your quiz. And this would be negative 3y minus 3, and that has the value of x, which is the same thing as that x there. So I can take negative 3y minus 3 times the 3 plus 9y, and then I just need to solve. Distribute negative 9y minus 9 plus 9y. Well, guess what happens? Negative 9y plus 9y, you get negative 9. Those are gone. But negative 9 does actually equal negative 9. This is a true statement. That means no matter what value you plug in for x and y, no matter what value you plug in, you're always going to end up with negative 9 equals negative 9. You can plug in 2 for y. And what? You're going to get negative 6 minus 3. So negative 27. And then 9 times 2 is plus 18. Hey, negative 27 plus 18, you're always going to get negative 9. It doesn't matter what the y is. That's what it means when there's an infinite number of solutions. Doesn't matter what the value of the variable is. There's an infinite, where's my word? There you go. Infinite number of solutions. So this tells me this is not my answer. Not answer. You must answer infinite solutions. If we had gotten a false statement where like 0 equals negative 9, that's not true. Solution. Infinite solutions. So when you're looking at it, if you have one solution, you have one ordered pair where the lines intersect. If you have no solution, you are looking at parallel lines because they have the same slope. And if you have infinite solutions, it's because it's the exact same line. Lines. Same line. If you put it in slope-intercept, the same slope and the same y-intercept. So tell whether the system has no solution or infinite number of solutions. Well, a couple different options you can do. If you like slope-intercept form, I've already got the first equation in slope-intercept form. So let's get the second one. Negative 2y equals negative 4x plus 14. Oh, divide by negative 2, excuse me. And y equals 2x minus 7. Well, that's the exact same equation. So that means that they're infinite solutions. I could have done it this way. I could have done this. Y equals all of this. So 4x minus 2 times 2x minus 7 equals 14. Distribute plus 14 equals 14. And this is 14, a true statement. And this here, if you want to do the elimination method, let's get the x and y together. Plus 2y equals 4. Plus y equals 4. Remember, they have to be equal. So what if we had negative 8x plus 2y equals 8? And if I subtract these because they're the same coefficient, that cancels these out, and I'm left with 4. 0 does not equal 4. This is no solution.